Welcome everybody. This is the answer key to our latest CER. It came from our second book on physics, so that's why it's called PS3. Learning Set 2 means it's from our second test. The book is divided into three learning sets, and it's number 4 because it's the fourth CER that we've written that we are going to be going over today. So first of all, you had the background information. And as you were writing the CER, hopefully this is the very first thing you did, that you read the background information. I can forgive you a little bit if you read this first, because this is not bad, because this will actually give you purpose of meaning. And this is ultimately what everything is based on, answering this claim correctly, because your evidence has to support the claim, and your reasoning has to explain why the evidence supports the claim. So if you don't get the claim correct, it's very hard to do well on a CER. So how much is the upward push force of the lower magnet on the upper magnet? So you were supposed to go through this background information, and you were supposed to be able to sift through all the evidence, because there's a lot of it here, and then figure out what pieces of evidence actually support your claim. Now, a lot of times people will write their claim first, and I would argue that you should never write your claim first. One of the things you probably want to do is look through the scientific principles. Because by looking at the scientific principles, if they're provided, some CERs you just have to use scientific reasoning to help you out. But if we're giving you scientific principles, you're going to have to use these to support your ideas. So by reading through them, you'll have an idea on what kind of claim to write, because you'll know what kind of scientific principles will support your claim. So what you really want to look at next then is your evidence. Don't write your claim right away. Look at the evidence, and then based on your evidence, write a claim. So when we look at the evidence, what I did was I broke it down a little bit differently this time. Here's the piece of evidence right here, and what I did is showed you where I found that piece of evidence. So one piece of evidence I found was, according to the free body diagram, only two forces, the lower magnet and the weight, are acting on the upper magnet because it is not touching the walls of the test tube. And then I drew arrows where I found that evidence in the paragraph or in the free body diagram. So this way, when you're studying this or looking it over in class, you'll know exactly where I found the evidence. Now, the evidence needs to come from this. A lot of you in your evidence said, oh, in class we did this, or we did this in a lab. No, based on this test, I want you to use this background information to come up with the claim. We're not taking it from other sources, because I want to know if you can read the background information and analyze the diagrams, put everything together, and write a good quality CER. So this is where you should be getting your information from. Now, another piece of evidence, the upper magnet is motionless. So I highlighted motionless. It says it right here. This is huge, and you'll see why later. Another piece of evidence you could have had is, according to the free body diagram, the lower magnet and weight forces are equal in strength or magnitude. Well, they have equal length arrows. So when you look at that, that's huge as well. Another piece of evidence they had, according to the free body diagram, the lower magnet and weight forces are acting on the upper magnet from opposite directions. So, and you might have had this, all combined with the last one in the same sentence, but these going in opposite directions is also going to be key to writing a quality claim, and the reasoning especially does support and connect your evidence back to the claim. And the last piece of evidence I thought was pertinent is, it was determined by using a force probe that the downward force of weight on the upper magnet was 150 newtons. So I highlighted where I found that. So even though there's not a lot of information here, or it seems like there's not a lot, I found how many pieces of data or evidence. There's one, here's a second one, here's a third one, here's a fourth one, and even a fifth piece of evidence. So you could have had all those things. Now, what you could have done is you could have just put them in a format that looks like this. If you want to type it all out in a long paragraph, you can. I would just bullet it. Here's a piece of evidence. This piece of evidence. This is a piece of evidence. Now, here's the one mistake a lot of you made. A lot of you took your evidence, and as soon as you list your evidence, you tried to explain it right away. No. When you have the evidence, just put the evidence here. You're going to explain it in the reasoning. Some of you even use scientific principles in this section. No, In a lot of ways, your evidence is the easiest thing to do. You just have to look for the facts. It's not opinion, but it's facts. It's based on facts. You have to go through the background information and just list the facts. So a lot of times this is the easiest because there's no opinion, there's no reasoning behind it. You just list the evidence. Now, once you have the evidence, now you can come back and make a claim. And your claim is just analyzing all the pieces of evidence to see what fits. Again, you want to look at your scientific principles to see if your claim will be supported by a scientific principle, because it should if we're including it. So here's my claim. And the question was, how much is the upward push force of the lower magnet on the upper magnet? The upward push force being applied at a distance on the upper magnet by the lower magnet is 150 newtons. Now that's huge. How much? 150 newtons. I had quite a few of you not mention 150. In fact, some of you didn't mention 150 newtons in your claim, your evidence, or your reasoning. This is huge because it says how much. Some of you just simply said, oh, it's the same. And you might have gotten away with getting proficiency in all three parts if you mention, especially if you mention 150 later in the evidence or in the claim, I might have given you a proficient for the claim. Or if you really had a lot of other background information. But it was really hard to be proficient overall if you didn't mention 150 newtons because it says how much. Now, here are the scientific principles. And when we look at these, several of these, in fact, you could probably use all of them in your reasoning, but they all don't work. And you're going to see which one of these I use in my reasoning. Now, my reasoning is I'm taking all my pieces of the puzzle. I'm taking all my pieces of evidence, my claim, and I'm trying to put it all together and trying to solidify it and explain once and for all why the evidence supports my claim. Now, to do that, this is going to be in a paragraph, and this is it. Now, you notice it is, actually several paragraphs. I could have wrote this all in one big paragraph. Some of you only had a sentence or two. No, you can't do that. Some of you just said, oh, the reasoning is supported, or the reasoning that I'm right is based on all my evidence. You have to explain everything here. So again, I'm going to start by restating the claim. The upward push force being applied at a distance on the upper magnet by the lower magnet is 150 newtons. So now I'm going to go into my scientific principles. And the one scientific principle that I think helps more than any of the other four is scientific principle number 1. So I'm going to state it. Scientific principle 1 states that forces that are applied to an object in opposite directions counteract each other. Now, some of you just listed the scientific principles. You didn't do anything else. You just listed them all. And you probably just copied and pasted them. But look at this. I say scientific principle number 1. Now I have to explain why or how that scientific principle takes my evidence and explains why my evidence supports my claim. So according to the free body diagram, the lower magnet and weight forces act on the upper magnet in opposite directions. That was one of my pieces of evidence. We also know from the free body diagram that both forces are equal in strength or magnitude, equal length arrows. That was also my piece of evidence. This would explain why the upper magnet is motionless. The two forces acting on the upper magnet must be equal, which would make sense because it states that forces that are applied to an object in opposite directions counteract each other. Now, if they counteract each other, doesn't necessarily mean it's not motionless. It just means they're going against each other. But later on, it said it was motionless. And you see that right here. So if they're going to counteract each other, and it's motionless, and we see that the two arrows act in opposite directions and are equal length, this would explain why nothing's moving. This would explain everything. And so the two forces acting in the upper magnet must be equal. Okay, so what? Does that help me? Does that finish it off? No. I have to have one more piece there. By using a force probe, it was determined that the downward force of weight on the upper magnet was 150 newtons. So again, I'm digging back into my evidence. And I'm coming back to this. So this sets me up and explains why they must be equal. So if they must be equal, big deal. Now I have to come back and answer the question, how much? 150 newtons. That's where I got the 150 newtons from. So now I'm going to talk about my claim. I'm going to state it, and then I'm just going to embolden it a little bit more and explain why. So by using a force probe, it was determined that the downward force of weight on the upper magnet was 150 newtons. Therefore, the upward force from the lower magnet must also be 150 newtons to keep the upper magnet motionless. Voila, that does it. That takes all my evidence. It takes the scientific principles and takes the evidence and explains why this evidence supports my claim. That's what you must have. Now, could you have used some other scientific principles? Sure. Here's some other things you could have had. You could have talked about scientific principle number 4. And it says that for every action, there's an equal and opposite force. I'd let you use it. It would be okay. But what that's really saying is if you're walking on the floor, your foot applies a force on the floor pushes back equally. Or when you're sitting on your chair, your butt's applying a force to the chair and the chair is pushing back. So that's really what that means. It's not necessarily talking about two separate forces, such as gravity pulling you down. And so gravity is pulling the magnet down. Well, the weight or that magnet, upper magnet, is also pulling up on the earth. That's where principle number 4 really comes into play. But if you used it and you explained why, yeah, I'm not necessarily going to mark it wrong. But that's not the only scientific principle you can have to get a proficient. And I also talked here a little bit about how the two forces, the lower magnet and the weight, are acting on it, and they're the only forces acting on it. So that took some more of the evidence I could have had and explains why I used it, or you could have used it that way. So when we go back to the evidence, did I need all 5 pieces of evidence? No. You know, I guess if I was going to go through back, these are the 2 that I was really looking for most of all. The upper magnet is motionless, and it was determined by using a force probe that the downward force of the weight on the upper magnet was 150 newtons. And these all supported these 2 big pieces of evidence. So if you didn't have all the evidence, you still could have got a proficient. If you had missed both of these 2 pieces, it was very hard to get proficient. Again, as you continue to work with quality, claim, evidence, and reasoning, you have to put the time into it. You have to put the effort. If you took the whole thing, it would probably be about 3/4 of a page of paper. So you can't just rush through it and do it as fast as you can because you're going to tend to miss key parts. So make sure you utilize your class time well when you have a CER test instead of rushing through it, because some of you were done really, really fast, and it really surprised me. And then when I graded your CER, now I know why you got through it so fast. As always, if you have any questions about writing CERs, make sure you come in and get help. Or you visit some of my online, if you go to my website, there's some places there, there's some things there that will help you. You cannot continue to say you don't know how to do evidence or you don't know how to write CERs if you never ask for help. If you're not asking for help, then you're basically saying, well, I don't know how to write CERs, nor do I really want to learn how to write CERs, because that's not going to help your test score. And you're going to see these again as freshmen. So as always, make sure you ask for help if you need it. Thanks.